Electric charge. The word electricity comes from the Greek electron, which means amber. The amber effect is what we call static electricity. Ben Franklin made the arbitrary choice of calling one of the demo situations positive and one negative. He also argued that when a certain amount of charge is produced on one body, an equal amount of opposite charge is produced on the other body. We find that the total electric charge of the universe is constant. Electric charge is conserved. Also, electric charge is quantized in units of E. The atom that has lost an electron is now positively charged. It is a positive ion. The atom that has gained an electron is now negatively charged. It is a negative ion. Some materials can become polarized. This means that their atoms rotate in response to an external charge. This is how a charged object can attract a neutral one. So you can see here in this diagram that initially we have here a plastic and a fur. Now initially neither this attract or repel, we don't know yet. But when the two plastic rods were placed near each other, then the plastic rods rubbed with fur repel each other. Because by rubbing in the fur, the plastic rod has been negatively charged. And therefore, they repel each other because like charges repel each other. Both positive repel each other, both negative repel each other. Now, when initially, on the second diagram, initially rods neither attract nor repel for the second rod. No? So, when the two plastic rods are rubbed with silk, they repel each other because they are now positively charged. On the next diagram, rods attract. Why? Because the positive and negatively charged rods now are attractive, meaning the charges now are opposite, so therefore opposite charges attract. Likewise here on the last diagram, this silk attracts the glass rod. So from that principle, in the law of electric charge, like charges repel, unlike charges attract. So for charge concept, we have opposite charges attract, like charges repel. Under the law of conservation of charge, the net amount of electric charge produced in any process is zero. The symbol for Q for charge is small q or capital Q. And the unit for charge is coulomb or letter C. In this diagram, we have here a particle electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. Proton also have the same number, 1.6 times 10 to the negative 19 coulomb. The neutron has no charge, it is zero. But the mass of electron is 9.109 times 10 to the negative 31 kilogram. And for proton, we have 1.673 times 10 to the negative 27. For the neutron, the mass is 1.67 times 10 to the negative 27. So to determine the number of electrons, we have the formula, the total charge divided by the charge of one particle, which is 1.6 times 10 to the negative 19. That is the formula to be used in determining the number of electrons. So, opposite charges attract. So, positive and negative attract. Like charges repel, both positive repel and both negative repel. Our body contains more than 1 times 10 to the 28 electrons. Why? Because anything that we put inside our body, the food that we eat, the liquids, the water, the vitamins, the food, the vegetables, the juice, water, contains atom. An atom contains electron and proton, and so with neutron. So the net charge of an object is the excess of either positive or negative charges as a result of the transfer of electrons. Another essential principle in electrical phenomena is the conservation of charge, that the net charge of an isolated system remains constant. For example, a system has two electrically neutral bodies, say rubber, rod, and fur. The electrons are held firmly in rubber than in fur, such that when they are rubbed, the electrons are transferred from the fur to the rubber rod. The rubber then has an excess of electrons, hence a negative charge. The fur, which has a deficiency of electrons, will have a net positive charge. Now, these are the different ways of gaining charge. By conduction, contact occurs between charged object and neutral object. The result will be two objects with the same charge. So, it's a conduction, there's a contact between the two objects. By induction, there is no direct contact. No contact occurs between charged object and neutral object. Two objects with opposite charge, so that will be the result. Induction means it is just placed near, like the two plastic rods a while ago, they were just placed near and they were able to get develop what we call electrical charge. By friction, that is rubbing two materials together, can rub electrons off of one and onto the other. So this is an illustration of how conduction occurs. Now before, you see here the white circle has no charge yet. But when this plate is placed near a rod, for example, during the negative charge rod now transfers negative charge to the plate, so but it is in contact. The rod and the plate is in contact now with each other. So some of the charges of the rod is transferred to the plate, the circular plate. And if you remove now the rod in contact with this circular plate, after you see there, it already had developed a charge, a negative charge. Before, we don't have a charge that is neutral. During the charging process, some of the charges are transferred, and then removing the rod, we have a charged circular plate. Now, by induction, meaning to say there is no direct contact. So here you can see here the metal sphere and the insulating stand. A metal sphere is initially uncharged, so there is no charge for the metal sphere. But when we place now the rod which is negatively charged near the sphere, electron deficiency here, the electrons pile up here, the charged rod brought nearby, so that is the process of induction. So by just placing near, some of the charges transfers. You can see here positive and negative for the sphere. Now, when we place a ground, a wire connected to the sphere to the ground, the negative charge is now collected in the wire connected to the ground. So that when we remove now the wire, now the purpose of this wire in practical life situation is that when you are going to wash your clothes and you keep on placing these wet clothes on top of the washing machine, there is a possibility that you may be electrocuted because the water will seep through the spinner and it will cause a ground to the electrical wiring. Now, to avert that situation, there is a what we call a ground wire at the back, a color green at the back of the washing machine. You have to connect that to a what we call rod being placed on the ground. So you are going to tie that wire connected to the washing machine at the back to a ground, so that even if you place the clothes on top of the washing machine, you will not be electrocuted. Why? Because there is what we call now a grounding mechanism. Now, if you remove now the ground, the wire attached to the ground, you can see here a pile of positive charge, no? By the process of induction. And then if you remove totally the rod near the sphere, at the end we have electrons on sphere rearrange themselves. The sphere has overall electron deficiency. So that is what we call the process of induction. Now, what is the difference between insulator and conductors? A conductor is a material whose conduction electrons are free to move throughout. Most metals are conductors. A conductor is a material in which excess charge freely flows. Metals are typically excellent conductors because the balanced outer shell electrons in metal atoms are not confined to any one atom. Rather, they roam freely about a metal object. Metals are excellent conductors of electricity and heat. For this reason, if a conductor carries excess charge, the excess is distributed over the surface of the conductor. So there are more metallic objects or elements in the periodic table. So these are called conductors. They are good conductor of electricity and heat. The insulator, a material whose electrons seldom move from one atom to atom. Most insulators are non-metals. An insulator is a material in which excess charge, for the most part, resides where it is deposited. That is, once placed in, it does not move. Most non-metallic material are good insulators. Balanced electrons are much more tightly bound to the atoms and are not free to roam about. Insulators are useful for studying electrostatics. So these insulators are a poor conductor of electricity. So, like for example, the equipment being used by the electrician are covered by red-coated rubber for the plier, for their screwdrivers, and so on. And even in wiring, it is covered with rubber so that you cannot directly hold on to the electricity. So insulator means it is a poor conductor of electricity. Examples of insulators, we have rubber, we have wood, plastic. So those are examples of insulators. For semiconductors, they have properties intermediate between conductors and insulators. Their properties change with their chemical composition. Semiconductors like silicon used in computer chips have electrical conductivity between that of conductors and insulators. Photoconductive materials become conductors when light shines on them.